This is another example of a box plot. So suppose a realtor recorded the sizes of houses measured in square feet which were for sale in the northern Kentucky area. The box plot below is a summary of that information. And what we want to do is make sure we understand how to read the different components of a box plot. So let's just go through real quickly what each of the arrow represents. So this is the location of the smallest value in the data set. So if you read down to the axis and figure out what number is sitting here, that would be the smallest house size. So we know it's going to be less than 1,000 square feet. And if this is 500 square feet, that piece maybe is about 100. So we might estimate that at 900 square feet. The left edge of the box is located where the first quartile is located. Let's call that about 1,200. In this case, we would say about 25% or 1/4 of the house sizes would be less than 1,200 square feet. That leaves 3/4 or 75% of the house sizes to be above that 1,200 square feet value. Now the middle of the box is labeled by the line dividing it into a left side and a right side, and this line is located at the median value for your data set. So this might be at 1,600 square feet. And what that does is says about half or 50% of the house sizes are less than that 1,600, while about half are above that size. The right edge of the box separates the next quarter of the data. So you've accumulated 1 to 3/4 of the data up to this point, and this might be at 2,400 square feet, for example. So then 3/4 or 75% of the house sizes would be less than 2,400 square feet, with 25% being more than that. And then the purple arrow on the very end is identifying where the largest house size is. And we can see that that is over 3,000 square feet, possibly at about 3,400 reading that axis. So some types of questions I could ask is just, what is the median house size? Remember, the median is where the line in the middle of the box is located, and that would be at about 1,600 square feet. Now the largest house would be the one that has the most square footage, and that might be somewhere around 3,400 square feet. So I'll change colors and try to make these line up. Now it says about 25% of houses are blank square feet or larger. So what value separates 1/4 of the values being above it and 3/4 of the values being less than that? So 25% of houses are more than the third quartile, which we said was about 2,400 square feet. Next, you're asked to identify the percent. So about what percent of houses are 1,200 square feet or smaller? Well, where is 1,200? It's about right here. So that's about the left edge of the box. So 1/4 or 25% of the houses would be smaller than 1,200 square feet. Okay. Now the middle 50% of sizes for the houses, well, how do you define the middle 50%? Well, remember the first quarter or first quartile and the third quartile or 3/4 of the data are within this region. So where the box is really covering identifies the central 50% of values in your data set. So we would say that the middle 50% of sizes for these houses is going to be somewhere between that first quartile, which was 1,200 square feet, and the third quartile, which was the blue number, 2,400 square feet. So if you were asked for the interquartile range, the difference in these numbers, 2,400 minus 1,200, would be 1,200. What about the smallest house? How large was it? Well, where's that leftmost edge of the whisker? Or if there were outliers, it would be a single point. But where is the leftmost value? And we said that this was about 900 square feet. So that's how you would read information from a box plot.